So let's discuss on snap through problem with the SMA wire as an actuator. Okay, so say we have a structure like this, okay, and at this moment this is an equilibrium configuration, okay, and if we apply a force, okay, if we apply a force and it will, this particular point will move downwards, okay, and if we keep on applying the force, suddenly at one point what will happen is it will go into another equilibrium position, okay, which is going to be, say, like this, okay, and even after I remove that force, I will still be in this configuration, okay. This is a stable configuration. I'll be in this configuration instead of this configuration. If I just apply a little force, I'll be moving from this configuration to maybe this configuration, okay, but when I remove that force, I will go back to this equilibrium configuration. But at the same time, if we apply the force enough, okay, or if I displace this point enough, then I will go back, I will come to this particular configuration, okay. So this is a snap through structure, and also it's a bistable structure, okay. So this one is one stable structure or a configuration, and this is another stable configuration. Now what we are going to do is we are going to switch between this configuration and this configuration, okay. There may be some applications, but let's not worry about the application at this moment. Let's just worry about how to switch from this configuration and between this configuration and this configuration using an actuator called a SMA actuator, okay, shape memory alloy actuator. Okay, so for that what we are going to do is, say, let me erase this part as well, okay, and so in order to pull to the other configuration, I have to apply a force, okay. So I have to apply a force using an SMA wire, okay, and let's say this is my SMA wire, okay. So this is my SMA wire, and when I heat this SMA wire, what will happen, it will pull this point, so that after a while, after it pulled enough, it will become this configuration, okay. So that I have moved from configuration 1, let's say this is configuration 1, okay, and this is configuration 2. So because of this SMA wire, I can move from configuration 1 to configuration 2, okay. But how can I go back? And for that, what I should do is I have to have another SMA wire, okay, which is connected in this direction, okay. So that's another SMA wire, okay. So basically when we want to have configuration 1 to configuration 2, what we will do is we will heat the let's call this SMA first, SMA wire 1, let's call this SMA wire 1, and this is SMA wire 2. What we will do is to go from 1 to 2, we will heat SMA wire 1, and the SMA wire 1 is supposed to pull not just this structure but also this SMA wire. Okay, so we will just heat the SMA wire 1 so that only this wire, the SMA wire 1, will get shrink. Okay, and while it shrinks, it has to pull this structure along with this SMA wire 2. Okay, and same thing it has to do the same similarly, what we have to do is we have to heat SMA wire 2 in order to go from state 2 to state 1. Okay, so that's the idea. So with this idea, we have a model for SMA wire. Okay, and we also know how to do the analysis if a SMA wire is connected with a spring, okay, in series. Okay, and use this idea, and we need to do a simulation for this particular structure. Okay, so that's the part of that's one part of the work. Okay, I hope that we're able to understand this part, and we'll discuss the other details later. Thank you.